All right, next section, 2.7. It's rules for polynomial equations. The first rule they give us, okay, is that if p of x equals 0, in other words, if this function, you set it equal to 0, and you have a degree of n, then it has n roots. Don't make this any harder than it is. If this is x cubed plus 2x squared plus x plus 1 equals 0, okay? That right there is what's telling you what you're looking at. That means there's 3 roots, okay? If it's x to the 4th plus 2x plus 1 equals 0, well, look at the biggest one, the biggest exponent. That means there's 4 roots. That's all that's saying. Now, the next two are very similar. The first one has to do with imaginary numbers. If you end up where a plus bi is a root, so let's say that you have 3 plus 2i is a root, then its conjugate here also has to be a root. So you're going to have 3 minus 2i. Okay? That works every time. Now, let's say they give you this. 5i is a root. Well, you're going, well, I don't know. Remember, this is 0 plus 5i. So the other one is 0 minus 5i. Or in other words, if 5i is a root, then negative 5i is a root. The next one, they give you all these words and it gets all confusing. Rational, irrational, coefficient, this and that, and all this other crap. Think of it this way. If I have, it's the same exact thing as that. If I have 1 plus the square root of 2 as a root, then 1 minus the square root of 2 has to be a root. That's all that's saying. Okay, it's a whole lot of words for very little. Just remember, if you have an imaginary number or an irrational number, then its conjugate has to be a root also. Okay? The next group, the next rule is number 4. And it says, if p of x is a polynomial, so if your function is a polynomial of an odd degree, then you will know that p of x equals 0 has to have one real root. Well, think about that. Whoops, forgot real. Real root. Think about it. If I have an irrational one, if I have 1 plus the square root of 2, I have to have 1 minus the square root of 2. I can't have an imaginary number now because I'd have to have its conjugate too. So it has to be some constant or real number. Anytime you have an odd, you have to have at least one real root. That doesn't mean they all can't be real, but it has to be at least one. Now, the next part, okay? It gets a little confusing the way they write this out, but we'll get through it. If I have a to the n of x to the nth plus a to the n minus 1 of x to the n minus 1 plus a to the n minus 2 of x to the n minus 2, all the way down to where I have plus a to the 0, a naught, times x naught, or x to the 0. Okay? And this all has to equal 0. Now, the one rule on this right here, a to the n cannot equal 0. All right? What they're going to tell you now is that find the sum of the roots. Well, the sum of the roots is equal to negative a to the n minus 1 over a to the n. And you're going, what does that all say? In other words, the coefficient, the leading coefficient, okay, that goes on bottom. So let's circle that in red. That goes on bottom. The coefficient of the next term, right here, goes on top, and I make it negative. So let's say I have x to the third minus 2x squared plus x plus 1 equals 0. The coefficient here is 1. That goes on bottom. The coefficient of the second term, that's the third, so I got to look at the squared term, is negative 2. So I have negative, negative 2. So the sum of the roots is just 2. That's all you got to do. Okay? Let's do another example of that. Let's say I got x to the fourth, 3x to the fourth, plus x squared plus 2. Well, now I got to look at it and go, okay, the sum of the roots, there's a to the n. Okay, so that goes on bottom. Negative 4. Now, what's the coefficient of the x to the third term? Remember, you got plus 0x to the third here. There's the coefficient right there. So this is just 0. And that's how you find the sum of the roots. All right? We're going to use this same thing here. All right? But now, I'm going to use the product of the roots. I got to find the product. I don't want to rewrite that whole thing, so it's going to take me a sec to get rid of this stuff. All right. There we go. The product of the roots is a little different. There's 2 different ways to find this thing. Okay? If this n right here is even, then it's going to be a naught. So this term right here, the constant, over the leading coefficient. And if n is odd, then it's negative the constant over the leading coefficient. Okay? So, how do we use this? Well, let's do a couple examples here. Let's start out with 4x squared minus 3x plus 6 equals 0. They say find the sum. Well, the sum is negative the second term off of that. So negative negative 3 over the leading coefficient, which is 4. So it's 3/4. The product is going to be equal to, well, here's where we got to look. Okay? Is n even or odd? Well, here, let me change colors. It's even. So it's positive. Okay? Constant. There's your constant. 6 over the leading term, which is 4. 3/2. There's my two answers. Okay, what if they give me this? 6x cubed minus 9x squared plus x equals 0. The sum is equal to negative the second term. Hey, look at that. Negative 9 over the leading coefficient, which is 6. So I have negative negative is positive. 9 over 6, reduce it to 3/2. There's the sum. Let's go back and find the product. Well, we look here, it's odd. So this means it's negative. The constant, well, what's the constant? There isn't one. It's 0 over 6, which is just 0. There you go. And you're going, okay, that's fun. When are we going to use this? Well, let me show you. They're going to give you that the roots of an equation are 1 plus or minus I. Find it. Well, holy diamonds, how do we do that? It's not hard. Find the sum. The sum is equal to 1 plus I plus 1 minus I. We just add them together. Well, that gives me 1 plus 1 is 2. Negative I and I drop out, so it's just 2. All right, we got the sum. Now we got to find the product. So now I got 1 plus I times 1 minus I. If I multiply those out, I'm going to get that this is 1 minus I squared, which is 1 minus negative 1, which is 2. So I got 2 and I got 2. And you're going, okay, good for you. Well, this is how this works. These 3 little dots mean therefore. You know, now you will know that x squared minus whatever you found for the sum times x plus whatever you found for the product is going to be equal to 0. So to find the equation, all I do is I take this, I go x squared, take the sum, minus 2x, take the product, plus 2 equal 0. There's my equation. Okay? So let's do one more of those. Let's say they give us that you have 2 is a root, and you have 4 plus I is a root. Well, here's the issue. Okay. You got to find, you know, there's a third root. It's 4 minus I. You got to have the conjugate, remember? If you have that, you have to have the conjugate. So what we're going to do is we're going to take this 2 and leave it out for now. Leave it alone. Find the sum of these two. 4 plus I plus 4 minus I. Add those. 4 plus 4 is 8. The i's cancel. All right, good. Now we're going to go back and we're going to find the product. That's 4 plus I times 4 minus I. If I multiply those out, I'm going to get 16 minus I squared, which is 16 minus minus 1, which is 17. If I write my equation for that, okay, I'm going to have x squared minus 8x plus 17, and that's my equation off of those. But remember, I still have this root here. So now I have to come out and go, okay, I also have x minus 2. And now all I have to do is distribute. X cubed minus 8x squared plus 17x minus 2x squared plus 16x minus 34. Combine your like terms, nothing goes with that. You got x cubed, I'm going to write it up here. X cubed negative 8x squared minus 2x squared is minus 10x squared. 17x plus 16x is plus 33x. And minus 34 equals 0. And there is my equation. And that is how you use the rules for polynomial equations. All right. Make sure you get this down and make sure you have questions for me when we get to the Zoom meeting. All right. Thank you.